In this video, we'll learn to verify solutions to equations. Remember that an equation is a mathematical statement that two expressions are equal. So, for example, part A says 3 plus 7 equals 10. This is an equation. We're stating that two expressions are equal, and it's a true statement, so we say that this equation is true. In part B, we have 2 equals 0. This is an equation. It is a mathematical statement that two expressions are equal, but it's false. So an equation can be either true or false. In part C, we have x minus 4 equals 17. Now the truth of this equation depends on the value of x. This will be true for specific values of x. And those specific values of x are called solutions to the equation. A solution of an equation is given by specific values of the variables that make the equation a true statement. For example, let's verify that x equals 3 is a solution to the equation x squared minus 3x plus 2 equals 2x minus 4. In order to do this, everywhere we see an x in the equation, we need to plug in a 3. So we'll have 3 squared minus 3 times 3 plus 2, and we're checking to see if that's actually equal to 2 times 3 minus 4. Now we need to simplify both sides. On the left we have 3 squared, which is 9, minus 3 times 3, which is another 9, plus 2. And we're checking to see if that is equal to 2 times 3, which is 6, minus 4. So on the left we have 9 minus 9, which are going to just cancel each other out. Then we're left with 2. And we're checking to see if that's equal to 6 minus 4, which is 2. We ended up with a true statement, which means that x equals 3 is a solution. In this example, we're supposed to check to see if x equals 2/3 is a solution to the equation 7x minus 3x squared equals 10/3. In order to check this, we'll plug in 2/3 anywhere we see an x in the equation. So we'll have 7 times 2/3 minus 3 times 2/3 squared. And we're checking to see if that's equal to 10/3. So we need to simplify the left-hand side. That gives us 7 times 2 over 3 minus 3 times, when I take 2/3 and square it, I can square the numerator of the fraction and square the denominator. That's one of our exponent rules. That's going to give me 4 over 9. And I'm checking to see again if that is equal to 10/3. 7 times 2 is 14, so I have 14/3. Then 3 over 9 can be reduced to 1/3, and so then this will be minus 4/3. And again, I'm checking to see if that's equal to 10/3. Indeed, when I take 14/3 minus 4/3, I can just subtract straight across the top and I'll get 10/3, and that is equal to 10/3, and so this is a solution. Let's check for understanding. Pause the video and work this one out on your own, and then come back and check your answer. We're supposed to check whether x equals 2 is a solution of the given equation. So I'm going to plug in 2 wherever I see an x. That will give us 6 times 2 plus 4 in the square root is equal to 2 plus 3. Now we're checking to see if this equation is true. Let's simplify what we have inside the square root. 6 times 2 is 12, and then we still have plus 4. And we're checking to see if this is equal to 5. On the left, that gives us the square root of 16, and we're still checking to see if that's equal to 5. But the square root of 16 is 4, which does not equal 5, and so this is not a solution.